Hello, everyone. Welcome to wasmCloud Wednesday for September the 14th. It's our community meeting. We've got a couple of exciting demos and a couple things to talk about today, so we can go ahead and get started. I'm going to hand it off to Jordan, who has a neat demo for us.
There. I have no promises this actually works. So yeah, diving down further into the world of Go providers. There was when I first heard thought about or heard about wasmCloud and wrapped my brain around it, this was the one demo I wanted to do, and it's not ready for prime time because it's a little wonky, but it's definitely good enough to demo. So let me see if I can find the right screen. So what I have done is I'm going to, on my other screen, I'm creating a link real quick to one of my actors. Okay, submit. Okay. So what I've done is essentially created a provider which provides an SSH connection into a chat client. And I have Monster over here on my local machine and Derpman over here on my remote machine. And it's pretty much just an interactive chat. This right window is supposed to be a user window. So obviously that's not working yet because you can't see the other users. But this is kind of cool and what I've been working on. And what this has led me to do, and through, with Steve and Brooks and Kevin, the Holy Trinity there, I've gone and I've taken the core TinyGo module or core TinyGo code and turned it into a module. And then also at the same time, the TinyGo actor code and the WASM actor code and the WASM provider code both made them into SDKs for writing Go things. So there was a little thing. There was code I had to move around, from core into actor, and then actor had to be massaged a little bit. However, it's led to a pretty nice experience for not only writing actors in Go, but also providers in Go. And if you care to look at this, so essentially what's happening is I have one actor in the lattice it's more or less acting as what it does is it watches the NATS channels where the chat, chat messages go back and forth. And then it kind of just takes it and then relays them out to the providers. And each host, like that, I think is my local one, and that's the remote one, has a copy of the provider running because that provides the SSH port connection. Yeah, and then like I said, this will not work yet because it's going to be based on a lot of PRs, right? So I've massaged the core, the core interface, and that's not, so don't worry about that. And also the actor code that is not on GitHub yet, the wasmCloud actor library, I've massaged a little bit. So I'm excited. I'm hoping to open a bunch of PRs, get a bunch of reviews from a lot of people here shortly. And yeah, hopefully kick rust out. I'm joking, everyone. And yeah, make Go a more enjoyable experience in wasmCloud. That's really it.
So Jordan, this is the actual thing that you ended up building, like the chat client. You run the provider wherever you SSH into the chat client, and then you can talk back and forth with anybody else who's connected to to the client?
Yeah, so the service it's providing is the SSH service. And then right now, because of some of the limitations with the Go actors, I think Kevin's WASI support will actually take a lot of this away. I'm actually building the terminal interface on the provider side. I want to move that to the actor side, because it's really just string manipulation in the end, and their string gets sent over, and the engine just displays it. So ultimately, what I want it to be is a SSH terminal provider that the actors can actually control. Right now, the providers, I think, doing a little too much work. But yeah, so the actor itself is what's connecting the providers to the NATS messaging system, where the messages kind of live.
Okay, yeah, that makes sense. It's just really cool. I know that we had a demo at one point for like a wasmCloud chat thing with a telnet provider, and seeing the little blinking cursor and the messages go back and forth is it's pretty cool. Brings me back to the old days.
Yeah, I didn't go with telnet. I went with SSH. I'm sorry.
That's fine. So and one other thing that you showed there, so the NATS messaging provider is the wasmCloud one, the Rust one, but your chat provider and the chat actor that you wrote, that's TinyGo and Go, right? I guess reverse respectively.
Yeah.
Very cool. Yeah, I'm really looking forward to those PRs, because the kind of stuff that you've been able to do with Go providers is really sweet, and having TinyGo and Go support and Rust support for both things would be really nice. That captures a large audience of people who are writing things on the server side anyways.
Definitely.
Cool. Well, anybody else have any other questions or comments or things for Jordan on the chat demo? All right. Thank you, Jordan. I think we'll move on. I actually have a demo that you all kind of got a sneak preview for before, but I wanted to show off the animal image generator actor that I wrote the other day in a little bit more detail. So hopefully we're on the right desktop here. What I was actually working on is making sure that when we came into our actor examples, that we had an example that used all of the different, or at least an example that used each capability that we have out there. And so I was thinking of what I could do for a Blobstore. I already had kind of worked on something that fetches a random cat or dog image, and I just adopted that to, instead of fetching it and returning it as an HTTP response, it will store that image on disk. So this actor needs the ability to make HTTP requests, receive messages. I could have done this with an HTTP server capability, but I thought it'd be nice to mix and match them a little bit. And the Blobstore capability so that it can actually save that image to disk. And there's instructions here for running it. This is a PR into the examples repo right now, but the code itself isn't actually it's not all that complicated. We receive a message, we make an HTTP request to download an actual animal picture. Depending on if it's if you ask for a cat or a dog picture, it'll ping a different like open free API endpoint for that. And then we just store that animal picture in a Blobstore. That's with this put object request, but since we're storing it in a container, which could be like a folder or a bucket, I create the container ahead of time, and then we just reply and we say, enjoy your picture. But that's it. This is all the code that you're actually going to see, and this is all in our examples repo, so not anything that you can't take a look at. But what I came in a little ahead of time, and I did a I started a couple things and linked a few actors together, or this downloader actor to HTTP client and messaging, nothing special. But you all may have not seen the file system or the AWS S3 Blobstore yet. So I was going to show what it looks like to configure those. So one thing that I'd like to go ahead and get ready, it's not in demo here. So I have this file on my local system. The way that the local file system Blobstore works, you give it a file root and it'll store things under the actor ID and then whatever container or anything that you have set up. So I'm going to link the image downloader to the Blobstore file system provider. We just provide the Blobstore contract, and then you just have to give it a root, which I have specified as like my temp directory. So as soon as you do that, you can actually come in and we can send a NATS message where, a pub would work fine, but we can send a request as well. Say, hey, I want to get a dog picture. So you ask for a dog picture, it'll create this container, the Brooks Demo animal pics. And look at that, we got a dog, pretty nice. We can do it again. This is actually a pretty naive implementation. It just kind of overwrites the same file over and over. We can also ask for a cat instead, and that will give us a picture of a cat. Or if we provide something that the actor doesn't know how to parse, we get a very reasonable default, a porg, just in case you send some garbage input. So this is cool. I had a lot of fun writing this. It's really neat to just kind of go through the motions of like writing an actor that'll work, receiving a NATS message, makes an HTTP request and stores in a Blobstore. But I got to thinking about it and I realized that we have more than one provider that implements the Blobstore contract, the other one being the AWS S3 Blobstore. So what I poked around with, and it actually worked on the first try, which I was very excited about. Not that I didn't think it was going to work, but just, it's, you hack around sometimes and you find out. I was thinking that we could actually hot swap while everything is running without changing any code to the S3 provider. So if I delete the Blobstore link from Animal Image Downloader, I can relink that with the S3 provider. And the only thing that the Blobstore, the S3 provider needs is your AWS credentials to actually talk to AWS, store things in S3, things like that. I am doing this in a way that is a little more, demo safe. I have like an environment variable file in my demo directory called aws.env that has my credentials in it. So basically, when we create this link definition, the things that we need at runtime are the AWS credentials. So we can swap out the link for the AWS Blobstore. And if I take a look at my little bucket that I have here, I created it ahead of time. The actor is resilient enough to create a bucket too, but just to make it easy, you got to like type in all this stuff. If I send this request for a dog picture now, that's it. Enjoy your animal picture. But on the local file system, this is still the same, the same animal picture. But if we come back to our S3 bucket, right, and we hit refresh, look, there's another animal picture. And if we open that up, it's a dog. So I just want to talk through kind of what happened right there at the wasmCloud runtime level. Connecting to capabilities is something that you choose at runtime. And so when I wrote my actor, it was with a Blobstore in mind, not with the local file system or not with S3 in mind or anything like that. So when I run this, I can link it to the file system. When I try to generate an image, it'll save that to my local disk. But then when I delete that link and I instead link the actor to the S3 provider, everything works the same. I didn't have to change or redeploy anything. It's just when I go to put the object, instead of putting it on the local file system, you put it in S3 instead, which is pretty sweet. I was very stoked to actually try this out because it gets me giddy, the kind of things that you can do with wasmCloud. It's real fun. So that is about it. I wanted to show that off because it's a fun example. Who doesn't like looking at dogs and cats? And it's also very, very practical. Hopefully you can see some of the ways that swapping capabilities can make like the transition from dev to production easier. That's kind of what I just did. I was working with local files, and then, then I went up to AWS where things would be running in the cloud. Or just makes things easier for people who want to change their implementation. I know that a lot of things like database connection strings and are things that you can change at runtime, but when you apply this to every capability your application has, the possibilities get really exciting. So does anybody have any questions about how this all works, what the code kind of looks like? I'm happy to kind of dive into that.
Brooks, I thought that was a really awesome demo. Are you, I think other people though, like when I think about somebody that's new to wasmCloud, how do you tell that story? I mean, is this like, what if moving from your desktop to the cloud or as easy as changing a variable, or, like, how do you explain this idea, do you think, to others?
Yeah, it's a good question. I think that there's a lot of ways that we compensate with current developer experiences, compensate for the differences between like dev and production. As I was going through this example, I realized that what a lot of people do, if you wanted to pretend that your service was going to talk to AWS S3, you would probably launch like a local Docker image or a Docker container with a service that acts like S3. But just because something like that is possible doesn't mean it actually makes your code any more resilient. Like you could swap out a Blobstore provider for, or it may be something like Azure Blob Storage. I don't know exactly what that is, but the benefits of coding your actor against a contract that gives you a little more abstract implementations of a service or abstract representations of a service, it only ends up paying dividends in the end. It makes your development life easier. There's fewer assumptions you have to deal with at the time that you're just writing the code, and the upgrades get that much easier. I think to go back to your original question, like how do you explain it to people? It's probably pointing out things, the hacks or the ways that they've gotten around differences before, and talking about if you take all of that and you put it at the wasmCloud, for in our example at the platform layer, then a lot of those pains and edge cases go away between your different environments. Yeah, there's plenty other ways that we can kind of extend this demo or things like this. Things that, excuse me. Sorry, John, I just saw your question. That example is actually it's in a PR right now going into our examples repo, but you'll be able to take a look at all the code and what it looks like. I forgot the track that I was going on originally. Oh, this is just one example of how you can hot swap capability providers to do different things. And I think that finding some examples where the difference between development and production is massive and causes a lot of pain gives us a good opportunity to show off why this is so powerful and so cool. Cool. Well, thanks everybody. That was I had a lot of fun putting that together and looking forward to doing more with it. Now unless anybody has another demo that they didn't let me know about, we can move on to kind of the wasmCloud community section, things that are happening in our ecosystem. And the first one that I'd love to talk about is this PR that Kevin put out on a Monday that had me like spit out my coffee for WASI support. Kevin, would you like to talk a little bit more about what WASI support is and what this PR kind of does for wasmCloud?
Yeah, sure. The main thing that I was trying to fix was a lot of times, especially if you're using Go, it's really easy to sort of accidentally produce a WASI module instead of a freestanding WebAssembly module. And so the first thing I wanted to do was just make it so that the wasmCloud host is more tolerant. So if you accidentally build a WASI actor, we're not going to throw a bunch of runtime errors when you try and start that actor. The next thing is that there's a lot of code and a lot of libraries that you compile. And again, we're not trying to point a finger at Go, but it tends to happen more often there because the WebAssembly support has just been a little bit further behind Rust. So what'll happen is you'll compile code in a library that emits to standard out or standard error. And if you do that on the previous versions of the wasmCloud host, it'll create a WASI target, and it'll use functions that the host doesn't supply. So the other thing I wanted to do is make it so that if you do have some simple code that emits to the standard IO stuff, that'll also work. And in the PR right now, if you emit to standard error, standard out, that'll essentially go off into the void, and we don't do anything with it yet. Once this is merged, there will be another PR coming very shortly thereafter that actually uses those pipes to emit the stuff from your WebAssembly module into our logs, and that'll even be compatible with our OpenTelemetry stuff. So the text messages that your actors emit from WASI will actually make it through to the distributed tracing stuff. So that'll be coming shortly after. So for the near term, what it means is that your stuff isn't going to break, and then we're just gradually going to add more and more features that leverage some of the WASI stuff. So hopefully this makes people's lives a little easier and reduces some points where there used to be a lot of unnecessary friction. I guess there's only one other thing I wanted to mention, which is sort of a security concern. If you've done some work with WASI before, you know that you can read from the file system, and you can read environment variables, and you can examine arguments. For security reasons in wasmCloud, the WASI-based file system is empty. There are no arguments and there are no environment variables. So while your code might not panic when you try and read those, you should expect that you're not going to get anything meaningful from it. So you won't be able to find any files on the file system using WASI calls. And yeah, that's about it.
Kevin, I have a couple of questions. The first one just around what you were just talking about with the file system, where if you try to read a file from using a WASI API or a WASI import, or do anything, it's just going to basically come up empty. Do we know, is that a specific import? The goal that I'm thinking of is if somebody tries to fetch a file using WASI, we would ideally we'd be able to tell them, hey, this doesn't work in wasmCloud, you should use this file system provider instead, or something like that.
Yeah, so the way WASI file system works is that the file system is essentially virtualized and snapshotted on its way into WASI when the engine starts. So if you've used like the wasmTime CLI to run WASI modules that read from files, you'll know that you need to basically point that CLI at a directory in order to add those files. What it really means is WASI modules don't actually have access to the file system. What they have access to is a virtual file system that's populated at module start. So the net effect of the wasmCloud security is that your virtual file system has no files on it. So you won't panic when attempting to access the file system, but you'll get like file not found if you try and go read a file.
Okay, gotcha.
And the same thing is true for environment variables and arguments. Those are all manually passed to the WebAssembly engine at start time. And when you're running the wasmTime CLI, it takes care of a bunch of that stuff for you automatically. But again, for wasmCloud to maintain its security, we essentially pass an empty list of arguments and an empty list of environment variables.
Okay. Do you think that there's a world where we would do a mixed WASI and wasmCloud, component model where you can, if you wanted to access a file, you could access a real-time file with a Blobstore, or if you were just hacking out like a simple example or something, you could start the wasmCloud runtime with a folder that has some static files in it and could access those.
Yeah, so again, it's kind of there's a difference in conceptual and abstraction level between the wasmCloud Blobstore contract and an operating system's directory or file system. So I don't think we would ever be at a point where wasmCloud would just let you use the WASI functions for accessing stuff that's inside, a Blobstore or whatever, because we would essentially have to map near kernel level system calls from what they really are in the engine to the wasmCloud stuff, and that gets nasty pretty quickly. But I think what is likely to happen is once the component model for WebAssembly is a little bit more mature, instead of people using the intrinsic WASI file system function calls, there will be a component model contract for accessing a Blobstore, and then anyone can use that contract, and then it's up to the host, whether it's wasmCloud or wasmTime or anything else, as to how it satisfies that contract. And so yeah, our integration with WASI is more just to remove it as a barrier rather than something that we're kind of doubling down on.
Okay, yeah, that makes a ton of sense. I was totally interested in the backwards compatibility of a WASI module that tries to read a file, how we can bring that into the wasmCloud ecosystem. But yeah, okay. And I had another question. That was all one question. With WASI modules and the way that they can kind of write to pipes, like standard out, standard error pipes, there probably is there's likely a future, I guess, with wasmCloud where we support wasm32 unknown and wasm32 WASI. However, if the future is just a only supporting WASI modules, which sounds reasonable with component model and better WASI or better support with WASI for standalone modules. Would we just remove the built-in logging contract? Just let actors kind of emit to standard out, standard error the way that they normally would, like with a logging crate?
It's a good question. I think, obviously nothing is set in stone and kind of still chewing on it, but I think it's similar to the difference between the raw file system access versus the Blobstore contract. Emitting to standard out doesn't do anything with log levels or formatting the log data as JSON or string or anything else. It's just raw byte dump. So while we still might support the raw byte dumping because it's actually kind of hard to get away from libraries that do that by default. And we would support that so that it's kind of there for backwards compatibility. But I still think that a wasmCloud or component model contract is still the right way to go in terms of logging, because it's more at that level, it's more of a rich feature set rather than just dumping bytes to a pipe. As to whether we would continue to support WASM 32 unknown as well as WASI, I think that's probably seems like a good idea. Again, just to keep all of the doors open that we can and reduce friction. One sort of interesting subtlety about the component model is that it doesn't actually require WASI. So if you're familiar with the component model standards, it's really just a way of allowing one WebAssembly module to communicate with another one, or a host pretending to be another one. Who satisfies the other side of the contract is agnostic, which fits in pretty well with the wasmCloud idea of how the world should work. But those standards they don't require, like the component model itself doesn't require WASI to work. Now, some of the stuff that is going to be, implemented as standards further down the road, like there's a possibility that some of these things like key value store and Blobstore and whatnot might end up being defined as contracts within the WASI umbrella. And if that happens, then you might need to turn on WASI support in order to get access to those. But that's down the road.
Okay, yeah, that makes sense. It's all interesting stuff, and I know that this is kind of forward looking, but it's for entertaining some of the smaller questions. Anybody else have any other questions for Kevin on the WASI, the preliminary WASI support PR? All right, well, I have one more thing I'd like to share, and then got a kickoff to Matt about his PR. I just wanted to share that WASH version 12 is officially released as of a couple of days ago. Had a couple hiccups in the actual release pipeline, which delayed this just slightly, but we have some huge implementations in WASH 12, including the WADM client, the subcommand WASH app. We've got the start command or WASH up is now fully released, so people can go out and start wasmCloud by just writing WASH up, which we're all really proud of. A lot of small fixes and big fixes for things like our CI and changing up some dependencies and improving the ergonomics of the actual crate. So big thanks to Matt Wilkinson, Connor Smith on the Cosmonic side actually surprised that this was his first contribution, but thank you. Thank you, Mo Feta, for the first contribution. It's really awesome to get new people coming in, like a surprise PR comes in and fixes a bug, which is always a lot of fun. And a huge thank you to Dependabot, the definitely real person who put in their first contribution. So big thank you there. There's a lot of changes in this one. Not a lot of them are hugely breaking. They're really just bug fixes and new features. But one thing I explicitly wanted to call out is on our documentation site, the overview and getting started has changed just a little bit. You'll see this is almost like a single page. The installation instructions are continuing to slim more and more down. So we've got, you know, the install instructions for your package manager of choice, or you can just use Cargo. And then the only thing you need to do before moving on to getting started is run wash up, downloads nats and wasmCloud and starts it all up for you. We're still maintaining our Docker installation instructions. This is important for people who really prefer to not install anything on their local machine. Totally fine. We keep the Docker Compose file up to date. And I've kind of migrated the older instructions into this manual install section so that whenever you go from just working locally on your environment and you actually want to launch wasmCloud on a server, that brings on an additional bit. You're not going to use an interactive command line to do that. So this is how you can still kind of install the host runtime manually. Going on to getting started, everything is pretty much the same other than showing you that wasmCloud logs are in a specific location if you use wash up. And that's about it. But I was really excited about this, just kind of slimming down our getting started guide, just to make it as easy as possible for people to get going. Let's see. I think that's it for that. One other thing I'd love to bring up, I know that this PR was just kind of pending and waiting while we were trying to get Wash version 12 out the door so we can start putting this into like alpha releases, is the Wash build PR. I think, at least last I saw, Matt, you're still on the call. Did you want to say anything about this? I know it's gone through a couple commits since we got to actually reviewing it.
Yeah, the only thing I'd say is that it's pretty close to being done in its kind of MVP state. I think it's pretty much approved by you and Taylor have taken a look at it, but we're just waiting on the V12 to go out before merging this in, which will then be O.13. Yeah, if people want to take a look at it, once it's merged as well, I'll make it an alpha release. So that we can then test it out and everyone can test it out. There are various actors to see if it works and see if you have any issues. Yeah, so let me know.
Perfect. Yeah, thank you, Matt. And I think you're right. I think we left some comments a while ago, and it's pretty much up to date and just needs I don't know if you've done it yet. Probably just needs a rebase with main and should be good to go. We'll give it another look and merge it in.
Yep, sounds good.
Alrighty. Well, that is all that I had from the wasmCloud community side. I think this is time for open floor. Anything about wasmCloud, broader Wasm community that anybody would like to talk about?
I know many folks may be excited about KubeCon North America 2022, the end of this October in Detroit, Michigan. Not only will WebAssembly Day be happening and starting on Monday, October 24th, schedules posted and live. Love to see as many people there as possible. But there will also be a wasmCloud booth on the floor all week, Wednesday, Thursday, and Friday, all day. If you'd like to come by and volunteer or hang out, more than welcome to join some additional swag for being on the conference floor, and you get to spread the gospel and good word of wasmCloud. So all are welcome to be a part of that, and I look forward to seeing everybody out there.
All righty. I think that's it then. Thank you, everybody, for coming. See you next week. Have a good rest of your day.